Okay, now I would like to talk to you about auto PEEP or air trapping. So before I talk to you or I show you a pathological example, I want to show you a normal example. So I'll go to the website, I will scroll down to the mechanical ventilation section, and then I will select normal lungs. All right, so here you see an example of a patient with normal lungs and standard ventilatory settings. I will pause the simulation now. So in assessing the auto PEEP or air trapping, it's important to be able to first visually recognize that by looking at the waveforms, and then you can do a more quantitative assessment by doing an expiratory pause. And so first, I would like you to focus on the flow waveform. So the flow waveform has two parts. That first part is active inspiration. This is when the ventilator is delivering positive pressure during inspiration. The area under the curve represents the volume delivered. And so if you calculate the area under the curve, it will be equivalent to the total volume that you set on the vent, since we are currently in volume control. This is the expiratory limb in the flow waveform. This is the air flowing out during passive expiration. In a patient who does not have air trapping, the volume that's expired should be equivalent to the volume that's inspired. In other words, the area under the curve here should be equivalent to the area under the curve here. So a quick visual assessment that you can do is to look at the flow waveform and see if those two areas are roughly equivalent. If there's a discrepancy and the area during flow is much smaller compared to the area during inspiration, then this would be concerning about auto PEEP. The other thing that you can do is to look at the flow limb towards the end of the expiration just before the next breath is delivered. Normally, if the patient does not have auto PEEP, then the flow should go back to zero. So note here that the flow indeed gets back to zero. So that's another measurement that you can do. If you want to do a qualitative assessment, then what you want to do is to do an end expiratory halt to calculate the total PEEP. And so I will let the simulation run now. The way you do it is that you click on the expiratory pause button. And then towards the end of the expiration, the ventilator is going to do a pause in the flow. All right, I'm going to let go now, pause the simulation. And so you can see that the line here remains virtually flat. And so that means that the patient does not have auto PEEP. Okay, now I will go into a patient who has air trapping and to demonstrate how the three things are going to be different. So I'll go back to the website, and then I'm going to select an obstructive process or COPD. All right. So this patient has an obstructive process or COPD, and then I will show you how to diagnose auto PEEP visually, and then how to do a quantitative measurement by doing the end expiratory pause. Okay, very good. I will pause the simulation now. So first, let's talk about the volumes under the curve. Again, when you look at the flow waveform, there's two phases. There's the inspiratory phase, and then there's the expiratory phase. And note that the area under the curve in the inspiratory phase is the tidal volume, so that's 500 milliliters since we have the ventilator in volume control. However, please pay attention to the expiratory limb. If you take note of the area under the curve here, you can visually see that this area is much smaller to the area under the inspiratory phase. And so that's concerning for auto PEEP and air trapping. That means that the air that leaves out is much smaller than the air that goes in. So volume out is smaller than volume in, and that means air trapping. The other thing that you should note here is that the flow does not go back to zero before the inspiration, and so you can see that the expiratory in the expiratory phase on the flow waveform that there is still flow right before the next breath is delivered. And so that limb does not go back to baseline, and you can actually hover over it and see clearly that there's still some flow here reported at minus 3.4 liter per minute before the next breath is delivered. And so that means that the patient did not finish expiring and is getting a new breath on top of air that's already entrapped that hasn't had the time to come out. So that's the second indicator of air trapping. The third one, now I want to show you how to do an end expiratory pause. So I will do that. And then toward the end of expiration, the vent is going to do a flow pause. And then I'll let go. Pause the simulation. Note here that you have a bump in the pressure. And so before the bump, you see that the pressure is set at the PEEP. So the airway pressure is 5. That's the set PEEP here. And then when I did the expiratory hold, you can see that the airway pressure is 6. So this patient has a total PEEP of 6 with an auto PEEP of 1. That's 6 minus 5 equals 1. That's the amount of the patient, that's the amount of auto PEEP that this patient has. And so again, this patient has air trapping or auto PEEP, which we diagnosed using 3 things. First, noting the discrepancy between the areas under the curve in inspiration and expiration on the flow waveform. Second, by noting that the expiratory limb in the flow waveform does not go to baseline or 0. And then third, by doing an end expiratory pause and calculating the total PEEP. Please note that for the expiratory pause to work, the patient has to be relaxed without intrinsic respiratory effort. Otherwise, the measurement is not going to be accurate. Last, one thing that you may see in patients who have auto PEEP is ineffective triggering. So I'm going to show you an example of ineffective triggering. So this should be a simulation, actually this one, sorry. This one here. So this one is a simulation for a patient who has ineffective triggering. So note that the patient tries to trigger the vent by initiating the inspiration. However, the vent is not delivering a breath here, and that's that can be due to auto PEEP. Okay, that's all for now. Thank you.